For decades, scientists have known that for sperm to succeed, they must complete a long and difficult journey. New research has shed light on how they manage their energy to make this journey possible. A study on bull sperm has revealed a fascinating dynamic between two key energy sources: glucose, a type of sugar, and lactate, a substance produced during metabolism. This discovery has important implications for both animal breeding and human fertility treatments. The core finding is that these two fuels make sperm swim in very different ways. When sperm are given glucose, they enter a state of hyperactivation, where they swim in an energetic zigzag pattern. This movement is essential for the final stage of fertilization, as it helps the sperm penetrate the egg. However, it is not an efficient way to travel long distances. In contrast, when sperm are given lactate, they switch to a more controlled straight-line swimming motion. This linear motility is like a car cruising on a highway. It's the perfect way to conserve energy while covering a lot of ground. Most importantly, the study found that lactate is not just a fuel, it's also a regulator. When both glucose and lactate are available, lactate takes charge. It suppresses the zigzag swimming induced by glucose and shifts the sperm's metabolism to a more efficient energy-producing process called oxidative phosphorylation. This process, which occurs in the cell's powerhouses, mitochondria, generates far more energy than the process used to break down glucose glycolysis. This research helps explain how sperm are able to adapt their behavior as they travel through different parts of the female reproductive tract, where the availability of glucose and lactate changes. Early in the journey, when efficient travel is needed, relying on lactate for straight-line swimming would be most beneficial. Then, closer to the egg, a switch to a glucose-driven, hyperactivated state would be ideal. The practical applications of this research are significant. In both veterinary medicine and human fertility clinics, sperm are often stored, washed, and prepared in special fluids. This study suggests that the composition of these fluids is critical. By creating solutions with an optimal balance of lactate and glucose, we may be able to better preserve sperm health, motility, and their ability to fertilize an egg. This could lead to higher success rates for artificial insemination in livestock and improved outcomes for patients undergoing assisted reproductive technologies like IVF. While these findings were in bulls, they open an exciting new avenue for research in human sperm, with the ultimate goal of helping more people achieve their dream of having a family.